Welcome to Everyday Mathematics. Today we are still on the 2023 Columbia University Integration B qualifying round and we move forward to part 2 where we'll be covering problem 11 to problem 24. And these are the problems 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So before I jump on to attempting to solve these problems, I'd like to encourage you, if you're here for the first time, please do really consider subscribing to our channel. Here at Everyday Mathematics, what we do is we go about and around and look at intricate problems and we try to solve and share with you. If you like what you see, please pause for a moment and do like our video. We also do encourage you to share our video if you do find them worth sharing. Without much ado, let's move forward to the solution phase of this video. So problem number 11, the indefinite integral of 1 over e to the 2x minus 1. What we can do here is rewrite our integral in such a way that we can divide both the numerator and the denominator by e to the 2x. So what this becomes is e to the minus 2x over 1 minus e to the minus 2x. And it's very important for us to know that if and this is just a by the way, if you have an integral such that it's a fraction, and the numerator is a derivative of the denominator, that integral results into the natural logarithm of fx plus the integration constant. Anyway, so we can re-express our integral here as, since this is a derivative of 1 minus e to the 2x times a half, then it means that our integral is half times the integral of 1 minus e to the 2x over 1 minus e to the 2x, which is the natural logarithm times a half of 1 minus e to the 2x plus c. The integral of 1 over e to the 2x minus 1 is a half natural logarithm of 1 minus e to the negative 2x plus c, or we can also rewrite it as half natural log of e to the 2x minus 1 over e to the 2x plus c. I think both those answers are okay. Again, as a by the way, In certain jurisdictions, natural logarithm can be written like that. Natural logarithm of x can be written like that. In our context, we choose to use just log without a base. So this is just for us to know. Problem number 12 is the indefinite integral of natural logarithm squared of x squared. So how I would choose to write this is and it's good to note that we had stated previously that in our case where you see ln x, natural logarithm of x, that is log x. So we choose to use log x. So using the rules of logarithms, what we do here is the 2 will go out there and then becomes 4 squared. And so let's say let u be equal to log of x, meaning that e to the u is equals to x, implying that eu du dx is equals to 1, and so eu du can be used to substitute for dx. So what this means is that our problem now becomes 4, and since this is u squared, eu du is our problem in the u domain, which becomes 4 u squared, the derivative of u is e to the power u is going to be the power u. So using integration by parts, where if you have a product of a function v and the derivative of a function u, the integral there is u times v minus u times the derivative of v, right? So using that, we're going to see that our problem is 4 uv is u squared e to the u minus the integral of u is e to the u, the derivative of u squared is 2u du. Okay, so we've come to a point where we have 4 u squared e to the u minus same as 4 u squared e to the u minus 2 u e to the u. We can use the same technique where we say now that e to the u is the derivative of e to the u, and so using integration by parts, we have u squared e to the u minus 2 u e to the u minus e to the u, derivative of u with respect to u is 1, and so what we have here is 4 u squared e to the u minus 2 u e to the u plus this and that. The integral of e to the u is e to the u times 2, obviously, plus the integration constant. So we have our problem, which is a solution which has gotten us to this C, but we said u is equals to log of x, and therefore e to the u is equal to x. So where we see e to the u, that is x, where we see u is log x. Using this, our integral of is equal to 4. U is natural logarithm, so we use that. Okay. X times x minus 2, and EU is x. Actually, this is 8, and then plus 8 x plus c is equals to 4x log squared of x minus 8x log of x plus 8x plus c. And that, ladies and gentlemen, was the answer that was required. So since we said our integral of ln x squared n is equals to 4 x, let's use the ln formalism just for harmonization's sake. Ln x, and this is squared, minus 8x ln of x plus 8x plus c. We could also express this as x ln or squared x squared, because we have twice of this, you are squaring this, and the 2 would go up, minus 4x ln x squared plus 8x plus c. So whatever works for you is fine, but that's also another way we would express it. Problem number 13, which is the integral of the x sine of x over the square root of 1 plus x plus 1 rather. So how do we do this? So first, when you differentiate that, you get, so obviously you have that over 1, and then there's obviously a half there. So what this means is that we can express this integral as times the derivative of twice that. And so this is, we can pull that 2 out. And that's what we have. Notice we can use integration by parts, where we say, well, we're integrating a product of v and a derivative of u, and that is, when integrated, is u times v minus u times the derivative of v. So with that in mind, we can say we can pull that 2 out, and then we have x plus 1 square root times the arc sine of x minus x plus 1 times the derivative of the arc sine of x. Okay, what is arc sine of x differentiated? That's an easy one. Differentiating arc sine of x is the same as 1 over square root of 1 minus x squared. So what this means is that our problem now becomes 2 square root of x plus 1 times the arc sine of x minus x plus 1 over square root of 1 minus x squared, close bracket. Okay, so we've come to here, x plus 1 arc sine of x minus x plus 1 over 1 minus x squared. So we can also see that this is the same as 1 plus x, 1 minus x. And this could go. So we have 2 x plus 1 arc sine over x minus the integral of 1 over, which is, and there's a 2 there, so which is x plus 1 arc sine of x plus 4 1 minus x plus c. In other words, when we integrate arc sine of x over x plus 1, that is 2 square root of x plus 1 arc sine of x plus 4 square root of 1 minus x plus c. And that is the answer. Problem 14, which is the indefinite integral of cosine of x over the square root of cosine of 2x. One thing I would like to do is re-express cosine 2x in form of sine x. So this is cosine x over the square root of 1 minus 2 sine squared x. And okay, what do I do next? Can I say let u be equal to square root of 2 sine of x? So du dx is root 2 cosine of x, meaning that 1 over root 2 du can be used to substitute for cosine x dx, right? And so what we have here is 1 over root 2 over the square root of 1 u squared. Okay, now we can now come back and say let u be equal to sine theta, and that means that du d theta is equals to cosine of theta, and so du can be used to substitute for cosine theta d theta. Okay, so meaning that now we have 1 over root 2 integral of cosine theta d theta over the square root of 1 minus sine squared theta, which is 1 root 2 cosine theta, 1 minus sine squared theta, square root is cosine theta, which is equals to 1 over root 2 integral of 1. So we have 1 over root 2 theta plus c, but we know that theta, but rather it said that u is equals to sine theta, meaning that theta is equals to the arc sine of u. Knowing that, we know that the integral of 1 over root 2 integral of du over square root of 1 minus u squared is equals to 1 over root 2 arc sine of u plus c. However, but what had we done? We had said that let u be equal to the square root of 2 sine of x. Since we had said that 1 over root 2 1 over root 2 arc sine of u plus c. Therefore, we're saying that cosine of x over square root of cosine of 2x is equals to 1 over root 2 arc sine of root 2 sine of x plus c. And that was our final answer. Problem number 15. This problem is quite involved, so we're going to go a little bit slower in trying to solve it. So the first thing I would like to do is I'll just say let u be equal to x squared, meaning that would be equal to 2x. Therefore, 1/2 of du could be used to substitute for x dx. And so to create a scenario where we have x dx in the numerator, our problem can be re-expressed, our problem which is x cubed integral x cubed 1 over x cubed times x squared plus 1 integrated can be re-expressed as 1 over x to the 4 times square root of x squared plus 1 x dx, which means that allows us to now import the half du, so we can just say half, we can pull that half out, and here we have squared u plus 1. So with that in mind, the next thing is we would want to bring another substitution and say let y be equal to the square root of u plus 1 such that y squared is equals to u plus 1, meaning that 2y dy du is equals to 1, so we can substitute for du with 2y dy. Okay, interesting. Now the next phase that we could do is from here we can see that y squared minus 1 squared is equals to u squared, and that is in reference to this guy here. So our problem half integral of 1 over u squared times the square root of u plus 1 can now be re-expressed as half squared is y squared minus 1 squared, and this is obviously y, and here we have 2y dy. So this and that goes, that and that goes. So our problem reduces to the integral of 1 over y squared minus 1 squared. Okay, so this is actually fun from here onwards. So we can now say this is the same as y minus 1, difference of 2 squared, right? Which is big bracket half 1 y minus 1 minus 1 y plus 1. Okay, we can now pull this guy out as a quarter. So we have a quarter integral of y minus 1 y plus 1 squared, which is a quarter integral of y minus 1 squared minus 2 y minus 1 y plus 1 plus 1 over y plus 1 squared. Okay, so we can now re-express this as minus 2 y minus 1 2 y plus 1. Okay, so this would cancel, and so now we can reintegrate this as a quarter, negative a quarter, 1 right, minus log of y minus 1 minus log of y plus 1. Yes, and obviously there's a quarter here, minus a quarter, 1 over y plus 1 plus c. Okay, so interesting. We've come to a quarter, y minus 1 minus a quarter, it's 1, and then we have a quarter log of y plus 1 minus a quarter log of y minus 1 plus c. Since we said y equals to the square root of x plus 1, not x but rather u, so it means that we are integrating our problem, that is a half squared, square root of u plus 1 is equal to square root of u plus 1 minus 1 minus a quarter square root of u plus 1 plus 1 plus a quarter log of square root of u plus 1 plus 1 minus a quarter natural logarithm of square root of u plus 1 minus 1 plus c. I think we could also have done ourselves some justice here by combining this. If we had brought out the quarter and we have y minus 1 plus y plus 1, that would be the same as 2y over y squared minus 1 times negative a quarter. That is something we could have employed. And obviously this 1, 2 here. So we would have a half u plus 1 over, so squared we have u plus 1 minus 1. Okay, and then from these two, this and this would have plus a quarter natural logarithm of u plus 1 over u plus 1 minus 1 plus c. So this is negative a half square root of u plus 1 over u plus a quarter natural logarithm of 1 plus 1 over u plus 1 minus 1 plus c. But our u was x squared. And so our problem is solvable to x squared plus 1 over x squared plus 1 minus 1 plus c. And that, ladies and gentlemen, is our answer. Problem number 16, the indefinite integral of sine 5x cosine 2x times cosine 2x. The first thing I'd like to do here is just do some quick identities here. So if you have sine A plus B is equals to sine A cosine of B plus sine of B cosine of A, sine A minus B is equals to sine of A cosine of B minus sine of B cosine A. So when you add sine A plus sine B plus sine A minus B, you get twice sine A cosine B, right? So half of sine A plus B plus sine A minus B is equals to sine A cosine B. Now, why I bother to do that is because I haven't memorized this thing. I just know this primary thing. So if I take, for example, this to be A and this to be B, what do I have here? So I have the integral of a half. Sine A plus B is going to be equal to sine 7x plus sine of 3x. So this means that I can now integrate these two positive 1 or negative 1 over 7 cosine of 7x minus 1 over 3 cosine of 3x plus c. So we could pull the negative out. But yeah, this is negative a half, 1 over 7 cosine of 7x plus 1 over 3 cosine of 3x, okay, plus c. And that's it. So problem number 17, we're just going to have to do a couple of things here. So let's try to re-express this as the indefinite integral of 1 over x to the half plus x to the quarter dx. And then we can pull x to the quarter out. So we have x to the quarter plus 1 dx over x to the quarter. So let's say let u be equal to x to the quarter, which means that du dx is equals to a quarter x 3 over 4, right? And so what that means for us is that du over x 3 over 4 is equals to dx, which means that 4 du over u cube can be substituted for dx. Therefore, our problem in the u domain becomes 1 over u plus 1, sorry, rather this is, so in other words, 4 u cube du over u from here, and this takes it to 2. So we have our problem now morph into squared u plus 1, which u squared minus 1 plus 1 plus 1 u plus 1 plus 1 over u plus 1. See, this and that cancel, so we have integral of u plus 1 plus 1 over u plus 1, which is equals to 4 u squared over 2 minus 4u plus the natural logarithm of u plus 1 plus c, which is 2u squared minus 4u plus 4 natural logarithm of u plus 1 c. But we had said that u be equal to x to the power 4, right? So in other words, the integral of this 1 over square root of x plus the 4th root of x is equal to 2 square root of x minus 4 cube root of 4 of x, 4th root of x plus 4 log 4th root of x plus 1 plus c. And that is the answer. We just say 2x to the half, 4x to the quarter, plus 4 log of x to the quarter, plus 1 plus the integration constant. Whatever works, good for you. Problem number 18 is fairly easy. This won't take much of our time, and that is the indefinite integral of 1 plus x all over 1 plus x squared. So what we do here is we just separate this into two separate integrals. Plus x over 1 plus x squared. And let's try to rewrite that plus in a good way that is easy to fathom. So this is a famous integral, which is the arctangent of x plus half the derivative of 1 plus x squared over 1 plus x squared integrated, which is tangent of x, pull the half out, derivative of the denominator over denominator, and that is easy to get that this is a half natural logarithm of 1 plus x squared plus the integration constant, and that is our answer. To problem number 19, the indefinite integral of 1 over the cube of 1 plus square root of x. I think one thing I may want to do is just say let u be equal to square root of x. And what that means is that u squared is equals to x, meaning that 2u du dx is equals to 1. And so 2u du can be used to substitute for dx. And so our problem in the x domain can be written as follows in the u domain. Okay, now sometimes it's just a little bit more cumbersome to deal with a 1 plus something in the denominator. We can now say let y be equal to 1 plus u, and so dy du is equals to 1, and so dy can be just substituted for du. And so our problem, which is 2 u over 1 plus u cube, can be now written as, in place of u here we have y minus 1. In place of 1 plus u cube we have y cube, and then du. So since we have 2 y minus 1 over y cube du, which is 2 1 over y squared minus 1 cube dy, sorry, here, this becomes 2 negative 1 over y minus, actually plus 2 y squared plus c. And since y was equated to that, it means that our integral in the u domain, which was 2u over 1 plus u cube, is equals to 2 1 plus u plus that and that cancels, so we just have 1 over 1 plus u squared plus the integration constant. So we've come to our problem where we have that being equal to 2, 1 plus u plus 1 over 1 plus u cubed squared rather plus c. But we say that u is equals to square root of x. Therefore, 1 plus square root of x cubed is equals to 2 over 1 plus square root of x plus 1 over 1 plus square root of x squared plus the integration constant. And that, ladies and gentlemen, is our answer. To problem number 20, which is indefinite integral of the square root of tangent of x. As is the case, or as is usual, we'll just say let u be equal to square root of tangent of x, implying that u squared is equals to tangent of x, meaning that 2u du dx is equals to sec of x, and that means that 2u du is equals to sec of x dx. Okay, and we can say that this is also same as 2u over sec square of x du is equals to dx, which is 2u plus 1 plus tangent squared of x. Du is equals to dx. This here is u squared, so we have 2u over 1 plus u squared du is equals to dx. And so we will put this in a rectangle so that tangent of x is equals, in place of square root of tangent of x, we put u. In place of dx, we have 2u, that's u squared, du, which is u, which is 2 u squared over 1 plus u squared du, which is 2 u squared plus 1 minus 1 over 1 plus u squared du, which is 2 u squared plus 1 over u squared plus 1 minus 1 over 1 plus u squared. So that cancels, and we do have 2, 1 minus 1 over 1 plus u squared du, which is 2u minus 2 arctangent of u plus c. But we are saying u is equals to square root of tangent of x. Therefore, the integral of square root of tangent of x is equals to 2 square root of tangent of x minus 2 arctangent of square root of tangent of x plus c. The problem number 21, which is the indefinite integral of cosine of natural logarithm of x. So as is the norm, we'll just say let u be equals to natural logarithm of x or log of x. And what we see here is that e to the u is equals to x. And as such, eu du dx is equals to 1, meaning that eu du can be used to substitute for dx. And so our problem now becomes cosine of the natural logarithm of x becomes cosine of u in the u domain, eu du. So what we have here is more of a cyclical problem. And so let's do this. Let's do this. Delete this and say, okay, I is equals to cosine of u eu du. And so this is the same as cosine of u derivative of eu, because the derivative of eu is the same as eu. So if I is equals to cosine of u times the derivative of eu, using integration by parts, v du being equal to v uv minus u dv. Using that, it means that our I is equals to eu cosine of u minus eu times the derivative of cosine of u du. So I is equals to eu cosine of u minus this is eu sine of u du. And so this also becomes eu cosine of u plus sine of u du. Using a nested integration by parts, this becomes eu sine of u minus eu times the derivative of sine of u. So we've come to I is equals to eu cosine of u plus eu sine of u minus eu times the derivative of sine of u du, which is equals to eu cosine of u plus eu sine of u. Yes. Okay. Minus eu cosine of u du. So this one here is I, and we can bring it onto the left hand side by adding both sides by I. So we have 2I is equals to eu cosine of u plus eu sine of u, and therefore I, we can pull eu out and say is half e to the u cosine of u plus sine of u plus c. But we said u is equals to natural logarithm of x. such that EU is equals to x, and therefore so since we said I, which is equals to the integral of EU cosine of u du is equals to a half EU sine u plus cosine of u plus c, when u is equals to natural logarithm of x, also EU is equals to x, then it means the integral cosine of natural logarithm of x is equals to a half x sine of natural logarithm of x plus cosine of natural logarithm of x plus the integration constant. And that is the answer expected. Problem number 2, problem number 22, the definite integral from x equals to 0 to x equals to 1 of the square root of 1 minus x squared. We're going to use two methods for this. We're going to have method 1, which is the simpler one. We'll say y being equal to square root of 1 minus x squared implies that y squared is equals to 1 minus x squared, which means that y squared plus x squared is equals to 1. So this is an equation of a circle centered around 0 with radius 1. So we have, right, and this is 1, negative 1, negative 1, positive 1. But it's from 0 to 1, and it's in the interval where this is positive. So this is the region where we're interested, right? So which is a quarter times pi times 1 squared, which is pi over 4. So easier. And that is it. Now let's use method 2, which is the harder method. Method 2, we say let x be equal to sine theta, such that dx d theta is equals to cosine theta, and therefore dx is equals cosine theta d theta. And so when x equals to 0, 0 equals to sine theta, and therefore theta is equals to 0. When x equals to 1, so 1 equals to sine theta, and therefore theta, sine of 1 is pi over 2. Therefore 0, 1, square root of 1 minus x squared is equals to 0, pi over 2, square root of 1 minus sine squared theta, cosine theta, which is equals to 0, pi over 2, times cosine theta, which is now equal to 0 pi over 2 cosine squared theta, which is the same as a half 0 pi over 2 cosine of 2 theta plus 1 is equals to a half sine 2 theta plus theta, which is equals to a half sine pi plus pi over 2 minus a half sine 0 plus 0, 0, 0, 0. And so this becomes a half times pi over 2, which is pi over 4. So therefore, integral 0 to 1, square root of 1 minus x squared is pi over 4. Is. So, problem number 23, which is interesting. Definite integral of natural logarithm of 3x squared over x times the natural logarithm of x cubed. So, just going to rewrite this in a way that I'm comfortable writing. So, right, knowing that log of AB is equals to log of A plus log of B, log of, C, D being equal to D log of C, using these two identities or rules, we're going to have log of 3 plus log of x squared over x times 3 log x, which is equals to log of 3 plus 2 log of x over, pull a third out, we have x log of x. And so we can say this is a third log of 3 over x log of x plus 2 log of x over x log of x. And so those cancel out. And then this is how we're going to proceed. We've come to a point where now we have a third and we have log of 3 over x log of x plus 2 over x. We can now create two separate integrals. Log 3 over x log x dx plus 2 over 3 1x. Now here we could say let u be equal to log of x, so du is equals to dx over x. And so if our problem is and we are focusing on this, so we have a third log of 3 over u du plus 2 over 3. This is log x. This is easy to see. So we have log of 3 over 3 log of u plus 2 over 3 log of x plus integration constant, but u was log of x, right? Our problem, which is natural logarithm of 3x squared over x let's use the original representation, not to get confused. X cube, x is equals to ln 3 over 3 ln of x plus 2 over 3 ln of x plus the integration constant. And that is the answer. Okay, let's move forward. Problem number 24, the indefinite integral of the arctangent of x over x squared. Let me try this. So let u be equal to the arctangent of x such that tangent of u is equals to x, meaning that sec u du dx is equals to 1. So sec u du can be used to substitute for dx. And so arctangent of x over x squared is the same as, in place of arctangent, we have u. In place of x squared, we have tangent squared u. In place of dx, we have sec u du. Okay. So now we have u tangent squared of u, which is cos squared of u over squared of u over 1 over cos squared of u. So this is u cos squared, right? And so we can express that as u, the derivative of negative of cotangent of u. Okay, so we've come to a point where we have u, derivative of negative of cotangent of u, du, using integration by parts, draw our usual box. Integration of v du is equals to u v minus u dv. Okay. And so this becomes negative u cotangent of u plus cotangent of u times the derivative of u du, which goes to 1. So we have negative cotangent of u plus the integral of cotangent of u. Tangent of u plus the integral of cotangent of u, which is u cotangent of u plus the integral of cosine of u over sine of u, which is u cotangent of u plus the derivative of sine of u over sine of u. And we know this integral where if we have the integral of the derivative of fx over fx log of fx plus c. Knowing that, and if we have it means that we have plus the natural logarithm of sine of u plus c. But we said u is equal to, what is u? U was this is interesting. What did we substitute? It was arctangent of x, or right? Let's try to write whatever we have in form of u. So u tangent is that plus the natural logarithm of square root of 1 minus cosine squared u plus c. So the problem becomes negative u over square root of 1 minus u squared cosine squared u plus c. Let's rewrite this in a decent way. Is equals to u over tangent of u plus log of minus 1 over x squared of u. This 1 minus 1 over 1 plus tangent squared of u. And so if u is equals to arc tan of x, that means that we have tangent of x over x plus log square root of 1 minus 1 over 1 plus x squared plus c. Okay, so since we brought the problem to where we have arctangent of x over x plus the natural logarithm of the square root of 1 minus 1 over 1 plus x squared plus c, we can reorganize that to plus a half natural logarithm of x squared over 1 plus x squared plus c. So in other words, arctangent of x over x squared is equal to over x plus a half C. And that is our solution. Maybe let's try a second method on that. I feel like the previous method is a little bit too winding. We have the arctangent of x over x squared integrated. And this can be expressed as arctangent of x times the derivative of -1 over x, right? So using integration by parts, where if we have the integral of v times the derivative of function u, when you integrate that, you get uv minus u, the derivative of v, right? With that in mind, we see that our problem becomes negative arctangent of x over x plus 1 over x times the derivative of arctangent of x. So what is that? So if, let's say, if u is equals to arctangent, let's use this expression. This means that u is equals to rather tangent of u is equals to x is equals to x, and so sec squared of u du dx is equals to 1, meaning that du dx is equals to 1 over sec squared of u, which is 1 over 1 plus tangent squared of u, which is 1 over, since tangent of u is x, so we have 1 over x squared. Therefore, the derivative of arctangent of x with respect to x is equals to 1 over 1 plus x squared, right? So if our integral arctangent of x over x squared was equal to negative arctangent of x over x plus 1 over x times 1 over 1 plus x squared, then we can express, I think let's just go back to writing arctangent as we had already started, over x plus, this is 1 over x minus x over 1 plus x squared, right? So that when you multiply the denominator, we have 1 plus x squared minus x squared, which is 1. So with that in mind, what we have now our integral arctangent of x over x squared being integrated being equal to arctangent of x over x plus 1 over x minus x over x squared plus 1, or 1 plus x squared, whatever way we want to look at it, is equals to, this is natural log of x minus a half natural log of 1 plus x squared plus c. And so we can now rewrite this as log x squared minus a half log 1 plus x squared plus c, which means that is equals to arctangent of x over x plus a half log of x squared plus 1 plus x squared plus c. Therefore, our integral of the arctangent of x is to arctangent of x over x plus a half natural log of x squared over 1 plus x squared plus the integration constant. And that happens to be our answer. So thank you so much. Without much ado, I hope you did really enjoy following along. If you haven't subscribed to our channel, we do really encourage you to subscribe to our channel. If you like what you see, please, we do encourage you to like or share to really give us some mileage on popularizing this channel. So until next time, bye-bye.